Good day. I'm Jinkili M. Kimeniano, and my report is about plate tower design. The design of a plate tower for gas absorption or gas stripping operation involves many of the same principles employed in distillation calculations. One of these similarities is the determination of the number of theoretical plates needed to achieve a specified composition change. Now, let's differentiate gas absorption from distillation. Distillation involves separation of components based on the distribution of various substances between a gas phase and a liquid phase, when all the components are present in both phases. In distillation, new phase is generated from the original feed mixture by vaporization or condensation of the volatile components, and separation is achieved by introducing reflux to the top of the tower. On the other hand, in gas absorption, new phase is also generated, but this new phase consists of an inert non-volatile solvent for gas absorption or an inert non-soluble gas for stripping, and normally, no reflux is involved. So what is reflux? Reflux is a part of the liquid from overhead condenser returned to the column to provide liquid overflow. Bubble cap and sieve plates are devices most widely used for contacting vapor and liquid in distillation columns. If high capacities are desired and where the resistance to gas flow is not a limiting step, these plates are also used in gas absorption. As shown in the figure, the liquid solvent flows across the plate and then through one or several downcomers to the next lower plate, and the gas flows through the bubble caps or perforations in the plate in cross-flow with the liquid. So as you can see in the figure, the gas and liquid flows in a cross-current manner. The figure shown is an ideal plate. In an ideal plate, composition of the gas and liquid streams leaving the plate are assumed to be in equilibrium. Now for the design procedures for plate tower. Construction of design diagrams should be an integral part of any design involving the distribution of a single solute between an inert solvent and an inert gas. As I've mentioned before in gas absorption design, there is also the determination of the theoretical plates or simply N. The number of theoretical plates can be stepped off rigorously provided the curvatures of the OL operating line and EC equilibrium curve are correctly accounted for in the diagram. Shown is a figure of a 3 theoretical plate system. So how do we determine the number of theoretical number of stages? First, plot the EC and the OL. Note that in gas absorption, OL is above EC, which is different in distillation. In distillation, it does not happen. And in gas stripping, OL is below the EC. X is the inlet liquor composition and Y is the inlet gas composition. From point X to Y2, draw step-up lines between the OL and EC until point X1, Y1 is reached. The number of theoretical stages is equivalent to the number of triangles formed or the number of times the stepping off touched the equilibrium curve. The method is just like the McCabe-Thiele method. There are instances when OL and EC are both linear. If OL and EC are linear, apply absorption factor method, which will be later discussed by my groupmate. Or we can use the Taylor-Tour equation shown in the slide. So that's all for my report. Thank you. Let me introduce to you the next reporter, Vanessa Carla Ayado.